So we're going to go over what interval notation is. You might have seen this before, but not everyone has. Let's say they gave you this. They put interval notation, they put a parenthesis, 3, 8, and then they put more of a squared off bracket around this number. So in this lesson, you're going to have to pay attention to when they put curvy parentheses or if they put the squared off bracket like that around it. The curve thing, that curve right there is like an open, like you start at 3, but it'd be an open circle on 3. You can start at 3 on a graph, but you're not going to color in the 3. It's open. And if they put the squared off bracket, that's closed. You know, like that one's included. You know, it's included. It would be a closed circle. It's included. It's like a closed circle. Okay, so when they graph these on the assignment, I noticed they do it kind of different though. I'm going to draw it. They do it kind of different. When you were in Algebra 1, I know you did a lot of like open circles and closed circles, but they don't do it like that in this book. They do it kind of weird. So I'm going to draw a little number line. 2, 3, 4, 5, 6, 7, 8, etc. Okay, so we're trying to tell you that you're going to start at 3 and go up to 8. That's what this is kind of saying. So in the past, you would have done it like this. You would have put an open circle on the 3, and then you would have went up to 8, and then you would have made a colored in circle on the 8. You remember doing kind of stuff like that? This book doesn't do it that way. They do it kind of weird. It's not that hard. They just draw it a little different. So I'll draw, this is how the book does it. But yeah, we're used to seeing it like that, so I'll draw it again. I just want to show you the comparison. The book does it this way. Okay, I'm making another number line again, same numbers. This is how the book shows it. Instead of doing an open circle, they, you know, like how this curvy thing stands for open circle, they literally put like a curve on the 3. It's really weird. I don't think I've ever seen this before, how they do it in this way, but that's how they're doing it. And then instead of putting the closed circle on the 8 again had that squared off bracket around it. They literally draw like a squared off thing on this 8, like a squared off bracket. That's how they do it this time. So I just want to make you guys aware of that. Even if you're in the back, if you already started working, guys, pay attention to that. They're not doing open circles and closed circles. They put a curve for an open circle. And they put a squared off bracket for a colored in circle when you include the 8. That's weird, kind of weird and different. You guys I know are used to open circles and closed circles when you've done them when you're younger. Now they put a curvy bracket and a squared off bracket. It means the same thing, they just show it a different way. So that's interval notation. Then we have what's called set builder notation. Some of your assignment tells you to put your answer in interval notation, and some of the assignment says put your answer in set builder notation. So let's write, I'm going to write the same answer, like the 3 to 8, the same answer, but I'm going to write it in the set builder notation. It's another way to write this same answer. Another way to show the same answer. Set builder notation uses they call these braces, I guess, like these squiggly braces around it. And they put, we're graphing like on the x-axis, you know, like on the number line, you use the x variable a lot. So you just say we're working on the variable x. It starts off like this. It says the set of all numbers x such that, this is how they read it. They say this is the set of numbers represented by x, and then they put a straight line that means such that, and then over here we put our answer. It's just a fancy way they do it. Okay, we just said we're going from like 3 to 8. 3 has an open circle, not included, 8's included. So we're going from 3 to 8. When you go between things, you can put like the x in the middle between the two numbers that you're going between. We're going from 3 to 8, between. The x is bigger than 3. Like, we're shading bigger than 3. So remember how when you do these symbols, the alligator eats the bigger thing? Like, you say, this means, like, x is bigger than 3. It goes like that. So I know that says 3 less than x. That means x is bigger than 3. You're going bigger than 3. And then you're going, the x, you're shading lower than or equal to 8. They would make it like that. That's how they would say the same answer in the set builder notation. So interval, they just like put the numbers you stop and start on. But the set builder notation always uses the greater than, less than signs. And I would graph it the same way and everything. So let's try another one. I'm going to write it in the interval way, and then we'll write it in the set builder way over here. Like, let's try another one, write it 2 ways. You know, get used to how to write it each way. The interval notation, let's say I gave you one that says -4 in parentheses, comma, infinity. How would you write that in the set builder way? It's kind of different, you know, the different ways to write things. Let's see here. Oh yeah, that's fine. You can probably just go up there after we're done with the notes. All right, set builder. Again, you might want to think, how is this graphed? Okay, the parentheses, the curves mean like when we graph the -4, it would be like an open circle. I'll write that in red. Like, these curves mean open. The curvy things around means open circles. Infinity and negative infinity are always considered open because you're not stopping on a certain number. It just keeps going up forever or keeps going down forever. So the infinity and the negative infinity, they're always considered open. So this says to go from like -4 to infinity. So how do I do that in this lesson? Instead of an open circle, they'll just put the curve bracket on the -4. And then you just shade like up forever because it says go to infinity. So that would just be like shading up forever, right? And that's why they consider it open, because it doesn't stop on a certain value. Yeah, so it's just a curve on -4. It's the same as an open circle, that curve. That's what they're saying. So how do you do it in set builder? All right, in set builder, they would write it the set of all numbers x such that it always starts like that. Okay, what do we say? How would we say this? Is this going like greater than something or less than a certain value? What do you guys think?
Greater than x. I mean, greater than -4.
Yeah, so you just say x greater than -4. Good job, you got it. This time, see, you're not like between numbers, so the x isn't between. Like the previous one we did, x was like between 3 and 8. But this one just goes one way, so you just say x is greater than this number, or x is less than this number. Yeah, when it just goes up to infinity or down to negative infinity, it's just going to be greater than that. X is greater than this, or x is less than this. That's the set builder way to say that. These mean the same thing, it's just different ways to write it. Okay, now, they build on this. They start asking you about these notations, and they start giving you number lines to shade. Okay, then they get kind of tricky. This is new. I know you have never seen this before. Then they say we're going to do something like 1, 4, that interval, 1 to 4. And then we did intersections and unions in the first chapter. Then they do intersect with 2, 8, let's say. And this is in the square. The 2 and the 8 have squared off brackets around them. They're going to do like intersections and unions with these. All right, so how do we answer this? Well, this intersection thing, you got to remember what that means. Do you remember what intersect meant if you had 2 groups of things? Do you remember what this intersect thing meant to do?
Take out the ones that are the same.
Yeah, it's like find what they have in common. I'll write that in red. What they have in common? Like where do they overlap? What do they have in common? The intersect was where they, you know, if this was numbers 1, 2, 3, and this was 1, 2, 3, and this was 3, 4, 5, they would have 3 in common. Like both had 3 in common. Find what they have in common. Okay, so 1 to 4. I mean, visuals help students a lot, so I'll just draw it. Okay, so the first one, 1 to 4. Okay, 1, 2, 3, 4, 5, 6, 7, 8, etc. Okay, so I'll just do like 0, 1, 2, 3, 4, 5, 6. I'll just make a number line. So the first one says like 1 to 4. It's kind of like telling you to shade from 1 to 4. We can do it like, you can do open circles if you're used to it. Okay, the first one, 1 to 4, means like numbers between there, right? 1 to 4, between. The curve means is like open. And then the second answer over here, I'll do another number line for that. 0, 1, 2, 3, 4, 5, 6, 7, 8, etc. Okay, the second set means to go from 2 up to 8. And those are like colored in dots. Those are included. They're the squared off brackets. So what do these two things have in common?
2, 3, 4.
Yeah, this starts at 2, 3, and just goes to like 4. Yeah, like 2, it's like 2 and up to 4 is what they have in common. So the 2's colored in on both, right? So the 2's included. The 2 could have a squared off bracket around it because the 2's colored in dot on both graphs. 2's colored in on both graphs. And it goes up to 4. But the 4 on this graph's not colored in. So what do I do?
Parentheses.
Just a parenthesis, yeah, not a squared off bracket. It just goes up to 4. So they overlap from 2 to 4. 2's included, but 4's not. So your answer, your final answer, if you had to graph the final answer, 2, 3, 4, you would put like it's a squared off, so you could put a squared off bracket at the 2, and then it would go up to 4, and then that would have a curvy thing on it. That's how they would graph it for the final answer. They would put squared off bracket, shade up to 4, curvy bracket. See, it's not too bad. It's just like where they overlap. If this symbol in the middle would have gone the other way, like a U, a union, then you would want to go from 1 all the way up to 8, because it would be all of it. Like this shaded part plus the other shaded piece. So then you would go from 1 all the way to 8 if this was a union. So I could write it down right here. If you had 1, 4 again, but union with 2, 8, I kind of like already know the answer. Like union means like all of it. So I would go, the answer for that one would be 1 all the way up to 8. And the 1 where we started, the lowest number you started on was 1. And that was curved bracket. But you could go all the way up to 8 and have that one the squared off bracket. See? That would mean, see, union means like all of it. Like this plus all of this. Union is like both sets, you know, like put together. Both sets together. So you'll have a few questions like that with intersection and union. Okay, then I'm just going to do 2 more examples with you and then you'll have time to work. I'm going to do an example that's a little bit harder with fractions in it because I know you'll start working and you'll have some easy questions and then you'll get to some tough ones. And I don't want to talk at you all day. I want you to have time to work. So I'm just going to do 2 more examples and then you'll have work time. We've done some fraction problems already, but they're always the most challenging. They're always like the challenging ones. The rest of the problems on your assignment have a lot of solving equations, and the equations have greater than signs, less than signs in them. Solving these inequalities, they call them. Okay, so here's a lovely fraction problem again. And we're going to try to solve this thing. All right, so again, when you have fractions, let's try to get rid of the fractions. How do you do that? How do we get rid of fractions?
Multiply by the least common denominator.
Yeah, take the whole problem and we're going to multiply by the lowest common denominator. What's the common denominator if you see 3s and 4s?
2.
Well, 3 doesn't go into 2.
Oh. 12.
Yeah, common denom. Let's put common denom. So you're going to multiply the whole problem by 12. Yep, 12. Like 3 times 4 is 12. 3 goes into 12 and so does 4. That's the lowest common denominator. Okay, so if you take 12 times the first fraction that says x plus 3 over 4, what happens if you take 12 times this first fraction? You'll get better as you keep practicing these. And when you see the fraction, 4 goes into 12. You're trying to get rid of the fraction. See? So if you times by 12, how many times does 4 go into 12?
3.
Yep, cross it out. This will be a 3. See? So it'll be 3 parentheses x plus 3. Then you go the same thing on the next one. Then you're going to take 12 times the next fraction in the problem. And then we'll take 12 times the last fraction. Hopefully you'll be feel better, feel more confident as you keep doing these. Okay, so now take 12 times this next fraction. What do you get?
4 parentheses x minus 2.
Good job. Because 3 goes into 12 4 times, so it'd be 4 parentheses x minus 2. And then last, what's 12 times 1/4? 3. Yep. See, now all the fractions are gone. Now you have more, I would just say more of a normal problem. No more fractions, and you should be able to do that problem. So I'll keep going quick. This would be 3x plus 9. Distribute. This would be 4x minus 8. Because you have to distribute the 4 on this side. Okay, so I got 3x plus 9 on this side. And that 8, this minus 8, and the plus 3 can go together. See, that's 4 times 2 was 8, so that's negative 8 plus 3. How much is negative 8 plus 3?
-5.
And then get your variables on the same side of the problem. So then I would minus 3x. That's just 1x. And then add 5. Add 5. What's that? 14, 13, 14. 9, 10, 11, 12, 13, 14. Yep, 14. There we go. X. Okay, so we worked it all out. Now, the final answer, I got 14 greater than or equal to x. Sometimes people like to put the x first in the final answer. It's really like x less than or equal to 14. You know, you can totally flip-flop that around. X is smaller than 14, less than or equal to 14. And then you could make a number line and graph it. You would shade lower than 14. So again, fraction problems are going to come up, and you got to know the thing about to get rid of fractions, multiply by the common denominator. Then after that, it was just a normal problem that you could do. They might have you, on the assignment, I do think they have you graph a lot of things. So the final answer, you could graph, you know, here's 14. It would be going less than or equal to 14. So they would have it like shaded lower than 14, like that. I'll just kind of make it shaded in dark like that. See, it's going lower than 14. They put like a squared off bracket on 14 because it was less than or equal to. They would have it like that. Okay, then one more example, like I said, just one more. Trying to show you the different kinds. The last kind that you're going to get is absolute value inequalities. These are the hardest ones, solving absolute value inequalities. All right, so we'll do one of these. All right, so let's say we have a problem that says -2 absolute value 3x plus 5. Close the absolute value, and then it'll have plus 7 equals, greater than or equal to, greater than or equal to -13. See, they get pretty long. This will be one of the harder ones, one of the harder kind you'll get to at the end of the assignment. So when you have absolute value problems, the absolute value, you know, has these lines around it, these straight lines around it. You need to try to get that part of the problem alone. That's the thing about absolute value. They say, get the stuff that's in the lines alone. Like over here, there's not just these things in the lines, there's a -2 in front of that, there's a plus 7. Try to get the part that's in the lines alone. How do you do that? Okay, you got a right idea. This 2, that 2 is like 2 times that. That's like -2 times that. No, you don't want to distribute, because it's not parentheses, it's the absolute value. Yeah, you're going to divide and -7. Let's do the -7 first. You want to undo the addition or subtraction first. You don't want to divide first because it'll mess things up. Then you'd have 7 divided by a 2 and you'd have a fraction. So first, yeah, you want to minus the 7. Okay, so first you want to minus 7. Okay, what's -13 minus 7? -20. Now divide, because this is -2 times this, so now divide by -2. So then I have 3x plus 5. Okay, when you divide by a negative, when you're working with these greater than, less than problems, do you know what happens?
Sign flips.
This greater than sign will have to flip it to less than or equal to. Whenever you multiply or divide by a negative, that you have to remember to flip the sign. So there's a lot of tricky things that you have to remember. So, like, make a little note. When you divide by a negative, you have to flip the greater than thing to less than. You have to flip the symbol. You have to flip that the other way. All right, we're still going. We're almost there. Okay, absolute value. We actually did some the other day. A lot of you had the coronation thing though. When you have absolute value, the inside of this, if this inside part came out to -10, it would still be okay, because remember, if you take absolute value of -10, you would get 10. So the thing they do now is they make this like a double. I like to make it like a double problem. We have 3x plus 5 less than or equal to 10. I think it's easiest to write, see, it was less, I write another one of those less than or equal to symbols here and put a -10. It's like this problem could equal 10 or -10. I make it a double problem. I really think it's the shortest way to do them. Just to remember that, oh, now I got to write 10 and -10 and put the less than or equal to the same. Some people ask if you flip that. No, you don't. You just copy the symbol you have right over to this side too. Copy the same symbol, 10, -10. Because of absolute value. The inside of this could come out to -10, and it would, absolute value of -10 is 10. That's why it's like a double two answer thing. And then you solve. When you're solving, you would -5. So I do it all like, it's like solving 2 problems at once. So then I -5 from each end. If you -5, you'd get -15 over here. And if you -5 from 10, you get 5 on this side. Then, see in the middle, that I'm working on the middle, like trying to get the x alone. So I had a +5, so I -5. Now what do? See in the middle there's a 3x. How do you get rid of the 3?
Divide by 3.
Yeah, just divide by 3, divide this side by 3, divide this side by 3. So you get x is less than or equal to 5/3 on this side. And this side, x is bigger than negative... Oh, what's 15 divided by 3? That'll work. That'd be -5. So it's like a double answer. That's the answer. It's like you would shade between -5 and all the way up, shade all the way up to 5/3. 5/3 is the same as 1 2/3. The graph would be shaded between -5 and 1 2/3. And they drew it in the book. I can show you. This is just an example from the book. They drew it right there. See, they did it like I did. And the answer, I know it's kind of, I gotta focus it. See, they -5 and then all the way up to 1 2/3. And they made the number line. So an absolute value problem turns into a double problem. That's the thing you have to remember about it. You get the absolute value alone, and you work on it till you get the absolute value lines alone. Then you equal it to the 10 and the opposite of 10, -10. It's kind of weird. It's easier to just do it double than writing 2 separate problems. Because if you write 2 separate problems, then people get confused of which way these signs go. Just copy that sign the same over here. That's a less than or equal, so this one also is a less than or equal. They're the same. It's kind of a weird one. Those would be the toughest ones. Okay, so you guys have work time. I can come around and help you as you work if you need help with getting some